We are starting with cones and frustum. It falls under the category of 3D mensuration. Now, the figure that you see over here, that is a cone. Yes, the same cone that we use for ice cream, the ice cream cone. Now, first of all, let me draw a few lines. Let me draw a vertical line like this. Let me draw a horizontal line like this. And let me just thicken one of the side in blue color. That is the third side. Now, first of all, this green line, that is the perpendicular height. Let me draw a perpendicular over here. The red line, that is the radius of the circular base. This blue line is the slant height. So H represents the vertical or the perpendicular height. This is the symbol that I use for perpendicular. So this is perpendicular. And then we have R. So R is the symbol that we use for the radius of circular base. It's a circle. It has a circular base. That is R, the radius. And then we have L. L is known as the slant height. Now, how are they related? So they are related according to the quadratic, actually, Pythagoras theorem. That is L square is equals to H square plus R square. That is how they are related. So let me just highlight this. This will be used up later. Now, what's in a cone? In a cone, we have a curved surface area. That is this thing, the curved surface area like this. So we have this thing, that's a curved surface, which naturally will have an area. And then we have a circular base. If I talk about a solid or a closed cone, then we have a curved surface area, we have a circular base. The formula for curved surface, so curved surface area of the cone, that is pi into R into L, where L is the slant height. Circular base, the area of a circle, that is pi R square. Therefore, the total surface area for a cone, a solid cone, that is the addition of these two, that is pi R square plus pi R L. But when we talk about a hollow cone, so if we talk about a hollow cone, we only have the curved surface area. So this is the curved surface. And this time, there is no base. Why? Because it is hollow. So therefore, the total surface area is the curved surface area only, which is pi R L. Now let's talk about the volume. The volume of a cone is simply 1/3 the volume of a cylinder. Just remember this rule, which is 1/3 pi R square H. That's the volume of the cone. So let me also highlight this. And over here, the total surface area of a solid cone is pi r square plus pi r L. Similarly, the total surface area of a hollow cone is simply pi r L. Okay. So if I join everything in one place, just like before. So let me write cone over here. Let me write solid or closed. Let me write open over here. The volume is exactly the same, whether we are talking about this or we are talking about this. Volume is pi r square h into 1/3. Volume is 1/3 pi r square h. When we talk about total surface area, for the closed, this is total surface area is pi r square plus pi r L. For the open, total surface area is simply pi r L. This is base and this is curved. This is only the curved because there is no base. So now keeping this in mind, let's start with some questions. The first question is very conceptual. The question says, a hollow cone has a base radius 6, slant height 10. The curved surface of the cone is cut, so they are cutting it and opened out in the shape of a sector like this. With angle x and radius r, it's a paper 1 question. Write down the value of r, calculate x. Now, first of all, let me just make thin lines. Let me draw a vertical line like this. Let me draw a blue line like this. Actually, let me draw a green over here. And let me draw a blue over here. Now, this 10 is actually the slant height. This 6 is actually the radius. And the perpendicular height is h in case they need this. So if they need this, let me just do some extra calculation. That is 10 square is h square plus 6 square. 100 is h square plus 36. H square is 64. Therefore, h is 8 centimeter in case if this is ever asked. Write down the value of r. Now, this r is for the cone. So let me make 2 columns. This is for the cone. This is for the sector. First thing is the slant height of the cone becomes the radius of the sector. So the slant height, and let me mark it over here. First of all, slant height L becomes radius of the sector, which is small r. So this r is 10 centimeters. That's the first part. What else is there? Calculate x. Now, if I want to calculate x, I know that the circumference of this base actually becomes the arc length of this sector. So circumference of the cone, which is 2 pi r, will become the arc length. Let me use the symbol S for the sector. So what is the circumference? So the circumference of the base, that is C, that equals to 2 pi r. R is 6, which is 12 pi. And if I use the formula, arc length, that is theta, which is x over 360 degrees, into 2 pi into r, over here, the r is the small r, which is 10 centimeters. So let's use the things. This circumference is this thing. So this is 12 pi. And then we have x over 360 degrees into 2 into pi into this r is 10. I hope you're getting this. Let's look at the diagram once again. This circumference over here becomes the arc length. This circumference is 12 pi. That's based upon this capital R. The arc length is x over 360 into 2 pi r. This r is this r. This r is this r. This r is this r, which is 10. So now some calculation. First of all, get rid of pi and the pi. Get rid of the 0 over here and the 0 over here. And then just go to the other side. So 12 into 36 divided by 2, that equals to x. So therefore, 2 ones are 2 6 are. And 6 into 36, x comes out to be 216 degrees. That is the answer. It makes perfect sense. Why? Because this angle is a reflex angle, and reflex angles are greater than 180, between 180 and 360. So this answer makes sense. Now, there it is, 216. Now let's try out one more question, just a basic question. They have given us the volume of a cone, that's 1/3 base area into height. The area of the curved surface of the cone is pi r L. They use the symbol small l. A solid cone has a base radius of 8, height of 15. Calculate its volume, calculate its slant height, its curved surface area, its total surface area. Now let me mark this in red. Let me mark this in green, just to give you the idea. And let me mark this thing in blue. So this is the slant height, L. I can do any part first. So let me write this thing, L square, 15 square plus 8 square. Let me grab a calculator. 15 square, I know it's 225. 8 square is 64. That comes out to be 289. So therefore, L square is 289. Therefore, L is square root of 289, which comes out to be 17. So this is 17 centimeter. That is the slant height. What about the volume? Volume is 1/3 pi r square h. What is r? Which is 8. What is h? Which is 15, the perpendicular. So 64 into 15 into actually divided by 3. That is 320. This is 320 pi. That is 320 into 3.142. I'll leave it for you to calculate. Its curved surface area. So curved surface area is pi r L. That is pi into r. 8 into L is 17. So 8 into 17, that is 136 pi. That is again 136 into 3.142. Its total surface area. Let me add the base area. That is pi r square, which is 64 pi. So let me add curved surface area plus the base area. So let me add in terms of pi first. So total surface area is curved surface area plus base area. Curved surface area is 136 pi. Base area is 64 pi. So 136 plus 64, that is 200 pi. That's a beautiful number. That is 200 into 3.142. Multiplying by 3.142, this comes out to be 628.4. Rounded up, that is 628 centimeter square. That's how the spot is done. And these questions over here, I want you to try it out for the next class. So I'll be uploading all the PDFs. Try out all the questions for the next class.